All right, so going on to page 2 of the notes, we're looking at exterior angles. So this is probably a new vocab word for you. So this is in reference to a triangle. So if we got a triangle here, we'll say triangle ABC. All right, if I extend one of the sides, and we'll extend side AC, all right, you're going to have an angle that's less than 180 degrees that goes back to the triangle. All right, so on this one, it would be this angle right here. All right, that angle is the exterior angle. Now, when we talk about exterior angles, we talk about the interior angles, and we classify them as one that's adjacent, and that's the one that forms a linear pair. And then there's also the two remote interior. So remote, just like the word, means kind of isolated, far away. Same idea with remote interior angles. They're removed and separated from the exterior angle that we're referencing. So in this picture below, if our exterior angle is angle BCD, all right, then our remote interior angles would be angle A and angle B. All right, so if this is the exterior angle, then the remote interior would be the two interior angles that are not connected. All right, so we're looking at these two over here. And we'll see a property that relates those here in just a second. And again, you may already see that because you know that the angles inside this triangle, if I add up all of them, they have to equal 180 degrees. But I also know if I add these two angles, that has to equal 180 degrees. All right, so when we look at this, that basically means that those two remote interior angles have to be same as the exterior angle. And that's our exterior angle theorem. It says the measure of the exterior angle of a triangle is equal to the sum of the two remote interior angles. All right. And again, that's because those two added together, plus that missing piece right here, which I'll mark in blue. All right, if I take that blue angle, right, that plus the two red dots over here equals 180, and that blue angle plus this dot equals 180. So those two red dots have to equal that other dot as well. All right, now we're going to use this in some problems, but first thing we're going to do is we're just going to identify the remote interior angles that are associated with an exterior angle. So go ahead and give this one a try. Pause the video and run through example 5. Then restart and I'll talk you through it just to make sure you're comfortable with it. All right, so hopefully you've now given example 5 a quick try. So first one, it says exterior angle is angle 1. All right, that's this angle here. So they're extending this side, which means our remote interiors are this one and this one, so 7 and 8. All right, now I like to clean up the picture after each one of these so that we kind of have a fresh place to start. So angle 2 is the next one. Angle 2, they've extended this side, so we're looking at 7 and 9 as the remote interior. All right, angle 3, going back to a clean picture, angle 3 is formed by extending this side. So our remote interior are going to be 9 and 7 for that. All right, now we can keep going through this process, and when we get to angle 4, all right, angle 4 is from this extension, so we're looking at 9 and 8. Angle 5 is going to be from extending this side out, so we're looking at 9 and 8 again. All right, and then angle 6, if I look at angle 6 is formed when we extend this side out, so we're looking at the remote interior angles of 7 and 8. All right, and again, we're just going through kind of piece by piece and considering the one extended side. And it says, note that angles 10, 11, and 12 are not exterior angles. All right, notice that one side of the angle is not a side of the triangle. All right, on exterior angles, one side needs to be a side of the triangle, and the other side needs to be the extended side. Whereas 11 that's made completely by the extensions. There's no portion of that angle that is the actual triangle itself except for the vertex. All right, example 6 is going to use this property that we talked about, which is that the sum of the remote interiors equals the exterior. So if we're using the shortcut, we can say 80 plus x has to equal 115. All right, and if I subtract, I've got subtract 80 from both sides, and I've got 35, so x equals 35. All right, now that's one option. Option 2, if I don't want to take that route, is I know I have 115 here, so I can use supplementary to get the inside, which would then be 65. And then I have 80 plus 65, all right, which is going to be 145 plus x, which would leave x at 35 as well, all right, because the sum of the angles has to be 180. And again, either approach is fine. There's good and bad to each approach. And you're going to notice that with all of these problems, we can take them in multiple ways. Now, often we'll see problems like B, where there's more than one triangle involved, and we're just going to take it piece by piece. So I'm going to work left to right on this one. So I know I have 1 as an exterior angle, so it's the sum of those two angles. So measure of angle 1 equals 46 plus 65, which is going to be 111. All right, I'm going to put that on my picture. Now, angle 2 forms a linear pair with that, so we're supplementary. So we've got 180 minus 111, all right, which is going to be 69. So measure of angle 2 is 69 degrees. Then we kind of hit a roadblock going from that direction, because now I've got that angle 2 that's right there at the top, but I don't know any other angles in that triangle, so I can't use my triangle angle sum. So now I'm going to flip to the right-hand side of the graph and work from that side. What I notice is I have an exterior angle, so I know that equals the sum of those two. So 142 equals 82 plus the measure of angle 5. Subtract the 82 from both sides. All right, and that gives me a 60 equals the measure of angle 5. All right, so you can drop a 60 in there. Then angle 4, I have vertical angle, so I can move the 60 there. All right, now at this point, I know that 69 plus 60 plus the measure of angle 3 has to equal 180. So I can solve that equation. So I've got 129 plus measure of angle 3 equals 180. And I'm going to subtract 129 from both sides. All right, and when I do that, I should end up with 51 for that last angle, angle 3. Now, since there's a lot going on in this one, I'm going to go ahead and summarize just real quick all the ones they asked for. So measure of angle 1 equals 111. Measure of angle 2 equals 69. Measure of angle 3 equals 51. Measure of angle 4 equals 60. Measure of angle 5 equals 60. Measure of angle, oh, there was only 5. So at that point, we made it through that problem. We've got all the missing pieces. Again, notice how we're using the fact that the exterior angle equals the sum of the remote interior angles. Right? That's kind of a key tool that we're going to have to get through some of these problems. All right, hope that helps with page 2. We'll be back with page 3.